We have covered a lot of trigonometry this year, and it's all super important, and in many ways it overlaps. So make sure that your trigonometry toolkit is well stocked. In this video, we are actually going to be adding to this toolkit. So when you write tests and exams, you'll get a formula sheet, and on that formula sheet will be these formulae that apply to triangles. So up until now, we've been working with right angle triangles, but now that we're in grade 11, these formulas are going to help us branch out and solve all kinds of triangles. But first, it's super important to check that the foundations are in place. So when it comes to trigonometry, this needs to be burnt into our memory. The way that I remember the trig ratios is by using the little saying SOHCAHTOA. And that reminds me that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, that's one of the first things I write down when I start a trigonometry test. And the reason we need to know this when solving right-angled triangles, that's what we've been doing up until now, is we use this formula here that helps us to determine the size of any length or angle. What we do is we take the side I want, the unknown side, and we put it over the side I have, and then we make it equal to the trig ratio of any angle. So for example, if I was asked what is the length of AB, and they told me that AC was 20, I could then say the side I want is AB over the side I have is 20. The angle that we're working with here is this theta that they've given us, so it's opposite over hypotenuse, and that is a sine ratio. Let's practice that with an example that you are more likely to see in a test or exam. So here we've got a bee. A bee is sitting on the ground X meters away from the tree that houses the beehive. Calculate the value of X if the angle of elevation from where the bee is sitting is 15 degrees. Okay, remember we've got angle of elevation, which is from the horizontal looking up. And if they asked us for an angle of depression, it would be from the horizontal looking down. Some terminology from grade 10 that you should remember. Okay, so this is a right angle triangle. That's the first thing I check, because that means I can use sine, cos, or tan. Now, what I want to do is I want to use my little formula that says I take the side I want, which at the moment is AC, X meters, over the side I have, they gave me that, 25 meters, and now it equals to do sine, cos, or tan of that 15-degree angle. So let's take the 15-degree angle, and then what we're going to do is we're going to say, okay, according to this triangle and this angle here, what is the hypotenuse? I always think the hypotenuse is the easiest one because it's across from the 90-degree. So there's H. Which side is touching the angle that I'm working with? The hypotenuse and the adjacent side. And then the other one is the opposite side. So now if I take a closer look, what I want, AC, is the adjacent side over the hypotenuse. And if you think back to SOHCAHTOA, that is actually cos of 15 degrees. So X over 25 is equal to cos 15 degrees. Let's multiply both sides by 25. So 25 cos 15. And we type that into the calculator. Make sure that your calculator is in degree mode, otherwise you're going to get all kinds of weird answers. 25 cos 15, and that gives us 24,15 meters. But what happens when I get a triangle like this? ABC. It's a scalene triangle. There's no 90-degree angle here, and so SOHCAHTOA does not apply. Well, that's when I head to my formula sheet and I have a look at these 3 new rules. Okay, I like to divide them into 2 groups. So the sine rule and the cos rule can go together, and then the area rule is a bit of a separate thing. Okay, because what happens is the sine and the cos rule, we use those to work out unknown sides and unknown angles. But the area is really just used to work out the area. The area rule is just used to work out the area of a triangle. So that's what I tell my students. If you've got options, start by trying the sine rule because it's the most straightforward. If you can solve your question or your triangle with that rule, then you're good. If you can't, then move on to the cos rule. And only if the question says something about area do you move on and try the area rule. It's also important to remember how triangles are labeled. So remember that across from vertex A is small letter a. That's the side BC. Across from vertex B would be small letter b, and across from vertex C would be small letter c. So looking at the sine rule, these are all sides and these are all angles. Okay, same story in the cos. The lowercase letters are sides. The uppercase letter is an angle. Let's test these out. First up, we're going to use the sine rule. So it says here, solve for the unknown in the triangles below. Let's take a look at the rule. So basically what I want is a side opposite an angle and another side opposite an angle. I don't need 3, I just need 2 of these to make it work. So what I do is I look in my triangle and I say, okay, here's an angle and the side opposite it is something I want. Then here's another angle and the side opposite that is something I have. So the sine rule is going to work here. And then what your teachers probably have told you is that you can swap this around. So you can write the angles on top as long as you do it for the whole formula and the sides at the bottom, or you can write the sides on top and the angles at the bottom. My hint to my students is always write the unknown on top because it is easier to solve when you get to the algebra part of the question. Okay, so in this case, we are looking for BC. That's a side. So we're going to write that in the numerator over sine 105 degrees is equal to, then we were given the 7 centimeters over sine 35 degrees. And then to solve this, I just want to get rid of this sine 105 in the denominator. And so what I do to the one side, I do to the other side. I multiply both sides by that sine of 105. So x is equal to 7 times sine 105 over sine 35. And we just pop that into the calculator. So that gives you 11,79 centimeters. This next example here, the unknown is an angle this time. There it is. Angle A, we don't know what that is. So let's check, do we have information across from that angle? We do. And do we have another side and angle pair? We do. So the sine rule is going to work here too. In this case, the unknown is that angle. So now I'm going to do the rule the other way around. So sine of angle A over side A, which is 10, is equal to sine of angle B, 63, over side B, 15. Okay, and then again, we're going to times by 10. Sine, I'm going to change that angle A to the Y, is equal to 10 times sine 63 over 15. Now what we've got here, grade 11s, is a trig equation. And when solving a trig equation for an angle like this, we have to get a reference angle and then apply it to all of the right quadrants. Now, before we carry on with this question, you may have heard your teacher saying something about the ambiguous case. And the ambiguous case can only happen with the sine rule, and it's because of this whole trig equation thing. So if you solve according to the trig equation rules, you shouldn't ever run into any problems. But let's quickly pause this question and just have a look at where this ambiguous case falls in and try and make sense of it from a trigonometric point of view. So the equation we need to solve is this one here, sine y equals 10 sine 63 over 15. Okay, and what we need to do is we need to identify whether or not this is going to be a positive or a negative value. So let's quickly punch that into our calculator. Sine y is equal to 10 sine 63 divided by 15. And we get an answer there of 0,594, etc. Okay, we don't want to lose any decimals. Now that's positive. And according to the cast rule, where is sine positive? It's positive in quadrant 1 and in quadrant 2. A for all, S for sine. Now, the reason that there's only an ambiguous case in the sine rule is because if we were to do the same thing with cos, we'd see cos is positive in quadrant 1 and in quadrant 4. Now, if you think back to your grade 8 geometry, you'll remember that every triangle just adds up to 180 degrees. So it's not possible to get an answer there in the fourth quadrant and still be part of a triangle because it's going to be bigger than 270 degrees. So in terms of sine, we need to do those two options. So once we get to this step here, we'll get a reference angle. How do we do that? We say shift sine, and then we type in that 0,594, or if you're worried about losing decimal places, type in the 10 sine of 63 over 15. There you get a reference angle of 36,41168, and now we can apply that. So in quadrant 1, the answer would simply be that 36,41 degrees. In quadrant 2, the answer would be 180 minus that reference angle, and that would give us 143,56 degrees. So now if we look at these two options, we can go back to our sketch and choose which one is the right one for our sketch. Okay, sometimes it so happens that it is both, or it could be both of them. There's not enough information, and that's what's called the ambiguous case. But when solving the sine rule for an angle, please make sure that you apply it to quadrant 1 and quadrant 2. So bringing our calculations back, what we should know is that the biggest angle is always going to sit across from the longest side. So if you're having a look here, we've got a side of 15 degrees, 15 centimeters across from 63 degrees. The angle we're working with is across from 10 centimeters. So it's definitely going to be the smaller of the angles. And so therefore, y is equal to 36,41 degrees. Now let's have a look at using the cos rule. So if we are asked to solve the unknown, so the length here of AB in the triangle below, if the question didn't specify that I had to use the cos rule, what I would do is I would start to say, okay, do I have an angle opposite the side I want? And then do I have another angle opposite one of the sides that I have? But here it's clear that I don't have enough information. Now the cos rule works beautifully when we have an angle in between two given sides. So that's called an included angle. Now that means we're going to use the cos rule here, but we're going to need to apply it to this particular triangle because now A is the subject of the formula, but actually we want side C. So I'm quickly going to have to do some working out here just to make sure that I substitute in the right thing. So that's side C, then this is side A, and this is side B. So what I'm going to do is I'm going to swap A and C in my formula so that it works out for me. So I'm going to say here C squared is equal to B squared plus A squared minus 2AB or BA cos of angle C. And now I can substitute in what I've got. So C squared is equal to, in the place of B, 13,2, in the place of A, 3,9, minus 2 times those two values, times by cos of 73 degrees. Let's pop that into the calculator. And that gives us an answer there of 159,3474 ... Okay, that's not the answer for C. C is not equal to that. C squared is equal to that. So let's square root both sides. Okay, generally when we introduce a root, we have to do so with a plus or a minus. But we are working with a length of a triangle here. And so we can only have a positive length in terms of the mathematical logic of the answer. And so if you don't write the plus or minus here, you won't be penalized. But now if we square root both sides, then we see that side C is equal to 12,62 centimeters there. Okay, so applying the cos rule, it definitely is more intricate than the sine rule, but it's not difficult. Okay, and then our last example says calculate the area of the triangle below. Now, the minute a question says area, I know that I'm working with the area rule. Now, in the past, to work out the area of a triangle, I've said half of the base times by the perpendicular height. But if I needed to do that, I would have to actually work out a perpendicular height and the length of the base, and that's just not always practical. So that's why this area rule and trigonometry is super helpful. Let's have a look at the triangle we've got. So triangle PQR, side R will be here, side P will be there, side Q will be there. So I've got side Q and side P. So that's going to be a change that I'm going to make in my formula there. Q and P instead of A and B. And that means that I need to use the remaining angle there, which is going to be angle R. So it's about taking a formula from a formula sheet and applying it to the triangle you have been given. So the area of triangle PQR, in this case, is equal to a half PQ sine of angle R. And now we're going to substitute in a half. P is 3,9. Q is 13,2. And sine of 73 degrees. Pop that into your calculator and you will get 24,62 centimeters squared, remember, for area, square units. And that's the area rule. So again, the rule of thumb, try the sine rule. If it doesn't work for you, use the cos rule. Unless the question specifically states that you need to work with area, then you bring out the area rule.